Hello, we are going to do an example we did not have time to do in class. We have a quadratic function given in standard form and we wish to find the 5 main features of it and use them to sketch the graph. We're going to begin by the easiest, so since this is given in standard form, finding the y-intercept is even easier than usual. So the y-intercept is a point that is in the y-axis. So the x-coordinate is 0, and then we need to find what is the result of applying the value 0 to the function. And it's this 1, because that's what the independent term is. We can also note that for the concavity of the function, since the main coefficient, the coefficient of x squared, is 2, which is greater than 0, that means that the shape of our parabola is like a smile, so we call it happy parabola, or we say that the concavity is positive. Now we're going to try to find what are, if any, the x-intercepts of the function. So we wish to solve the function equal to 0. So we want to know for which values of x 2x squared plus x plus 1 is equal to 0. We're going to apply the quadratic formula for this. So we are trying to, we're going to use here that the value of a is 2, the value of b is 1, and the value of c is 1 as well. So applying the formula, we get minus b, so minus 1, plus or minus, and we have then the square root of the discriminant. So 1 squared minus 4 times 2 times 1. And out of that, we need to divide it by 2 multiplied by a, so 2 times 2. So we have here minus 1 plus minus, and then inside the square root, we have 4 multiplied by 2 multiplied by 1, so that's 8. So we have 1 minus 8, so that's square root of minus 7, and then divided by 4. But well, doesn't matter what we have. We have here something that we cannot solve. We cannot find the square root of negative 7. That's not a real number, so that means that we have no solutions. So what's going on? Let me just quickly sketch what we know so far and try to get an idea of what's happening. So I have my axis here, and then we know that the function is going to cross the y-axis here. It's going to have positive concavity, and it's not going to cross the x-axis. So that means our function could be looking like something like this, or roughly something like this. We don't know exactly, but it's not touching the x-axis. So we are not able to find the x-intercepts. The problem we have here is that usually when we are trying to find the x-intercepts, we also want them to be able to find the axis of symmetry, because we know that the axis of symmetry is going to be halfway between the x-intercepts, whatever they are. But what if there are no x-intercepts? Well, then we have to find another pair of points that are at the same y level, so they are at the same height, so they have the same image by the function, so that we know that the axis of symmetry goes midway between them. So for instance, I don't know, if I find that there is a point here and then there is a point here, then I know that the axis of symmetry has to be somewhere around here. So when I fold the quadratic, those 2 points coincide. But we don't know those 2 points. We don't know yet such a pair of points. But what we know is one point over here that is a y-intercept, and that is at the point 0, 1. So we're going to try to see if there is another point in the line y equal 1. So if there is another point that is a point of the function and has y-coordinate 1. So if we find such a point, then let's say, I don't know, I find that it's here, then we're going to have to find what is the midpoint between the y-intercept and that new point. So what we are trying to solve, well, I'm going to delete that because I don't know what it is, such a point, if it exists. So what I'm going to try to solve is can it be that 2x squared plus x plus 1 is equal to 1 for other values of x other than for 0? So this is what we're trying to solve for x. So that means we want 2x squared plus x to be equal to 0 because we are canceling 1 on each side. And we can solve this by taking x as common factor. So we get 2x plus 1 has to be equal to 0. Well, this has two solutions. We already know that this is true when x is equal to 0. And we are seeing here that this is also true when x is equal to minus 1/2. So that means I'm not using the same scale in the x-axis, so the picture looks a bit better. At this point, minus 1/2, the image, so the result of applying the function is also 1. So it's the point over here. So now we know that halfway between the 2 points, so here in the picture, has to go through that point, the vertical line that is the axis of symmetry. So we are going to write that for finding the axis of symmetry, we need to find the midpoint between minus 1/2, 1, and 0, 1. So the midpoint is minus 1/4, 1. So that's what this point over here is. So then by symmetry, the axis of symmetry has equation x equals minus 1/4. If you prefer to write minus 0.25, negative 0.25, that's fine. So we got the axis of symmetry, so now we know a little bit more about our quadratic. Let me write axis of symmetry x equal minus 0.25. It's just missing the vertex. So we need to find what is the result of applying our function to the point minus 1/4. So we need to find what is m at that point. So let me just write here, we are trying to find minus 1/4 square multiplied by 2 plus minus 1/4 and plus 1. We know this has to be a positive result because we don't want to cross the x-axis, and we also know that it has to be lower than 1 because we want to have positive concavity as well. And doing the computations here, so 2 multiplied by 1/16 minus 1/4 plus 1. Here I cancel 2 with 1 factor 2 from here, so we get 8. We need to take a common denominator to be able to sum this. So 8 is going to be my common denominator. I have 1 for the first term. The second term had denominator 4, so I need to multiply by 2 the denominator and the numerator as well, so minus 2. And then instead of writing 1, we can write 8/8, so that's going to be plus 8/8. So this gives me is 7/8. Positive less than 1, and then we can write, I'll write it over here, vertex minus 1/4, 7/8. And it's gonna be a minimum, of course, we already knew that. So now we can more or less complete the sketch of the function we have over here. This is y equals m of x.